Well, good morning, everybody. Hello. Good morning. And welcome to another RMHAM University. As always, I have to remind you that RMHAM is a 501c3, and we are always looking for folks to help us both with their time and their money. So, for example, today you have one of these little routers that you can take home because we have had donations from people that make these things available to all of us to do classes like this, as well as, of course, maintain our network and all of the individual sites. So again, to the extent that you can, Wayne in 0POH here is our treasurer, and he would gladly accept any donations. Cash check or credit card. And of course, Colorado Gives Day is also coming up in about a month, and Colorado Gives Day, RMHAM will have a presence. So if you can support us there, we would very much appreciate it. Is this thing talking to me?
Yes, it's an echo.
Rob, can you make this thing not talk to me?
Well, while they're doing that, the syllabus isn't up on the link yet. Yes. It is now. Refresh
the page. Yay! Today our presenters are myself and John Maxwell, but we also have our illustrious AV team here. Dirk, who just came to the rescue. Rob back there, Mark over here, and Dave. So thank you again for all the efforts that you putting this together. These guys were here last night setting everything up, so it's very much appreciated.
We did it in an hour and a half last night.
Well, that's a lot faster than last time.
Yes.
So very much appreciated. So anything else you want to say?
No.
Okay, so everybody has a router, a power supply, and a way to power everything, and then you're plugged into this router remotely, right? Don't expect anything to work at this time. In fact, if it works, something is wrong. But make sure that you grab the syllabus, because the slides will show you the steps that we're going to walk through, so we want to make sure that you have that. Make sure that you have Winbox installed, and then put your laptop in wireless mode, because one of the things that I have personally never done, but I have heard of people who have done this.
Turn wireless mode off.
Is that you basically log into the router and you reset it, and you've just reset a router on the mountaintop.
You said put your computer into wireless mode. You mean turn wireless mode off.
Oh, sorry.
Yes.
Yes. Put it in airplane mode. That's what I meant. Just so that you don't, by accident, end up in the wrong device, that you're just connecting to the device that you're physically connected to. So you want to do the first few slides?
Absolutely.
Ignore the notes.
I don't even know what that means.
The notes are from a previous session.
What is Router OS? Router OS is a product that has been created by a bunch of Latvians back in the early 90s. It's Linux-based. All of these devices that you see here, regardless of what they are, is running a Linux kernel that has been compiled for whatever piece of hardware you have. This operating system is the same on every one of these devices. The way it works is the same on every piece of hardware. The $15 router in front of you, the $1,000 router laying here, all the same. It runs on every piece of hardware, whether it is a router or a microwave radio, whatever it happens to be. They also make a version that's called a cloud-hosted router, CHR. It's an x86 PC, Intel-based software that you can create a very fast router on a piece of hardware or in a virtual. So it'll run on pretty much any platform out there. They've got this for everything. They have multiple license levels. The device that you have sitting in front of you Do we have one of those that we can show and tell here? All right, so this is the little, this has even got paint spray on it. That's nice. The little device that we have here, 3-port wireless router, is $15. This is a level 3 home device.
Actually, that's a level 4.
This is a level 4?
Yep.
Okay, most of the time these are level 3s. The 4 to 6 gives you the ability to do access points and a few other things out of the box. Since this one is a level 4, it would let you do a WISP, wireless ISP access point, and a few other things. Even though it's pretty anemic with the processor, it's not very fast. Whenever you get one of these devices, they are free for lifetime updates. So whatever the newest version of software is, be careful with that. Their stable version is testing. So just so you know, we're on long-term on almost every device that we have out there, which we only get a few updates a year, but those few updates a year are pretty solid. If you start using the stable stuff that they have, you are going to have issues. So what you've got here, I think these are all on the same version, right?
They're all on 648.5, which is long-term.
Okay, 648.5 is the most current long-term version. And Willem went through probably, what, 50 of these?
Yep.
At least, and upgraded them all the same. And for the guys here in the room, these are yours to keep, so you take these with you. So 648.5 is the current long-term operating system that Mikrotik has out there.
It's called either long-term or bug fix, depending on
Bug
what version.
fix is old. That's what they used to call it.
It's long-term support.
They call it long-term.
Yeah, the
Right.
newer ones,
Stable and in test.
yeah, the newer versions all call it long-term, and that's what you should use if you're trying to build a network. Like for the guys in Glenwood Springs, Ski Country Amateur Radio Club, who's here today, they do Mikrotik also. And if you start using newer stuff, things will break and they get very unpredictable is probably the best way to put it. We've also found that it adds latency if you use some of the newer versions, which is very bad for people using voice over IP applications. Advantages of Router OS, like I said, same software on all hardware. If you look, this device here is a $1,000 36-core Mikrotik router. This is made by Mikrotik. It's called a Cloud Core. It has 4 SFPs and 12 gigabit Ethernet ports, and it's a 36-core tile processor. Same operating system as this. They work exactly the same way. They present with all the same options. They have all the same functionality. This device, this 2-foot dish, it has a Mikrotik Net Metal 5 on the back of it, 2-watt radio, really, really high power 5 gig radio. It goes out of band if you get the international version, same operating system. This unit, which is called an LHG Light Head Grid, same operating system. You see a pattern here?
Still running Grand Junction.
Yeah. All of these devices are the same for whichever ports they are. If you'll notice these routers, they say Internet 2 and 3.
And it works
Consider that to be port 1, port 2, and port 3. Okay? Doesn't matter what they are. You can make these ports do whatever you want. They are completely flexible, completely configurable. And one thing to remember, they're the same on every device. So if you've got a wireless radio, if you've got an RB2011, this is what most of our network runs. They all do exactly the same thing. You configure it and tell it what you want it to do. If you'll remember, when we start getting into this a little bit, it's really, we're going to tell you what ports to use as part of this lab today. But the most important thing to remember is you can make it anything you want. It doesn't matter. So you've got an SFP port here, which is designed for fiber. That SFP port can have the same functionality as an Ethernet port, can have the same functionality as an Ethernet port on here. Doesn't matter. It's whatever form factor it happens to be using. When you take this device out of the box, all ports are designed to be routed. There is no bridges on these devices generally. When you take a cloud core out of the box, all 24 ports on here are generally set up so that you create the config that you want, and it will do whatever you tell it. And remember, it will do whatever you tell it, whether that's right or wrong. They're really easy to configure. The GUI, the user interface that these things use is called Mikrotik Winbox. And it does run on Windows processors, but it runs just fine on Macs under Wine. So if you have a Mac and you're running it under Wine, that's all I use. I use a Mac and I only run it under Wine. I don't run any of the multitasking software like, what's that? Yeah, whatever you happen to use, you don't need that. Wine, very small, runs perfect. The command line tools are extraordinarily powerful. It's a bastardized private language, but you can do everything in the router from the command line. And
Some things you can't do to do it.
some things you cannot, but it's getting better by the day. Every time they release a new one, it does something different. Connecting to the internet is the next slide here. Do you want to talk about this a little bit? This one seems
So
like...
Ben is insisted that I insert this slide. The particular configuration that we're going to set up here today is for a trusted network. So we're not going to do anything security-wise other than set the password. But if you are going to be using this device and connecting it to the internet, you really need to know what you're doing. Security is not for amateurs. So first of all, use a strong password. That's sort of your first line of defense. But you really need to put up a good firewall between it and the internet. And that's a whole nother class. So we're not going to cover that today. So don't use this configuration that we're going to use or configure today if you're going to plug it directly into the internet. If you use QuickSet, there is actually a firewall that it generates for you. So that's fairly okay, but just don't do it. The way that we configure firewalls in RMHAM is that all of the routers that touch the internet have a firewall that's managed by the FTP, which is one of our tools, and it basically makes sure that you can't get in from the outside. The other thing that you can actually do is disable the services. So you can actually tell it this device will not accept SSH or HTTP or various things like that. Just be careful that you don't completely lock yourself out in the process. But the long and the short of it is don't use this configuration on the internet because that's going to be a severe problem. So as far as what we're going to do today is we're actually going to use Winbox. Now there's actually 4 different ways that you can configure these devices. Winbox is by far the easiest. It's a nice GUI, and you can actually access the device even if it doesn't have a configuration in it at all. It talks to it via its MAC address, which is really convenient. WebFig works almost like Winbox, except it's HTTP based, and if you've blown away the configuration, the HTTP can't connect. So you can do it for subsequent steps, but once you've got into Winbox, you might as well use it.
It does get a little bit odd to try to use the WebFig because they put things in slightly different places, and it looks different.
Right, because it's HTML, right? But if that's all you have at the time and you really need to get into it, that works too. Of course, the command line is really where all true geeks go. So you can SSH into the device and configure things. And for some things, it's actually easier to use the command line because you can use up arrow to go back to the last command and just edit it. So if you want to add 5 ports, you do port 1, up arrow, change the line, port 2, port 3, and so forth. So
Ben, KC2VJW doesn't believe that there's a GUI.
we just haven't taught him the GUI yet, but he'll be here in a little bit. And then the other thing is there's actually an API where you can actually talk to the device using a well-defined protocol. And so, for example, our tools like DevDB uses that to configure the firewall, make sure that the configuration is standard and all of those kinds of stuff. So that's a very nice feature overall, but again, beyond today's class. So what we're going to do today, of course, is Winbox. As John said, it is basically a Windows executable. If you're a Windows person, that's no problem. On both Linux, which I'm running here, and OS X, just run it under Wine. It works just fine. It's typically the best way to do your initial configuration because it talks at level 2. So all you need is a MAC address. And then for some of the advanced configuration, the CLI is sometimes more convenient, but you can basically do pretty much everything in Winbox that you can do from the command line. And then the other thing that's nice is there's actually a feature called RMHAM, which I forget what the acronym stands for, but the idea is you've accidentally blown away the config on this device, and it is a 4-hour drive to get there. However, if you can actually connect to another device that is connected either by a wire or by a Wi-Fi to it, you can actually Winbox into the adjacent router and then use with RMHAM and then use it to connect to the next router on level 2, which has saved our butts a few times.
Mac Telnet and the command line is another function too. It's just a little harder to operate in the command line.
Right. And so what we typically do is we do the initial configuration with Winbox and then do the rest with either DevDB or the command line to do that. Yes. Thank you. So what we're basically going to do, this is just a quick outline of what we're going to do here today. So typically what you would do is blow away the existing configuration. Since these devices that you just got, you have no idea what's currently in there, we always start by basically blowing it away or doing a hard reset, and we'll go through that in a minute. Then we use Winbox to do the initial assignment. So typically we do things like name the ports. By naming the ports, you know what's physically plugged into that particular port, which is very convenient if you're trying to talk to the DMR radio that is in Akron and it's not talking. You can go into interface list and say it's connected to Ether 4. Ether 4 isn't running, so a mouse ate through the cable. Now we know what the problem is.
We call that a rodent-induced failure.
So typically we would do that and then do the address configuration. And then for the advanced configuration, things like setting up OSPF or setting up the firewall or something like that, we would typically use a different tool just because it's more convenient to do like batch updates of a lot of things that way. So you use Winbox to do the customization, then we use these other things for the more advanced settings. There is a quick set option in these devices that we don't use for our devices because it's the walled garden kind of approach, right? It's sort of what Apple does is, this is the way we're doing things. Well, I want to do something different, right? So once you've done the quick set, it's basically set a bunch of configuration that you don't really want and you have to undo. So we typically just skip that altogether, but it may actually be convenient if you're really just starting out with Router OS to just set an initial configuration and see what it looks like. Here's what we're going to do. We're going to first do a hard reset on the device to reset all of the configuration. We can either do that with the reset button or just log in and blow it away. Then we're going to set the system ID just so that you know what device you're talking to, right? You're not configuring your buddy's device, which happens. And we're going to set a password, which is just another way to make sure that you're in your device and not in somebody else's device. Then we're going to label the interfaces. So we're going to set what happens where, just so it helps us with the later things, so we know what the next step is. We're going to create a bridge that basically maps all of these ports. And then we're going to set IP addresses. And the worksheet is intended to help you figure out what IP addresses to set. We'll do some basic routing configuration. We'll configure DNS. And normally we would do a software update, but I've already updated them, so you can skip that step. But this is pretty standard in any configuration that we would do. So the device what we have here today is called the Hap Mini. It basically has a 650 megahertz processor in it and 32 megabytes of flash. The operating system uses about half of that, so you don't have a lot to spare, but Router OS is pretty good at updating that. We've got 5 ports on this. So the obvious 3 is the 3 Ethernet ports on the back. It also has 2 gigahertz Wi-Fi in it. And then these devices actually has a power line driver too, that you can actually use the building wiring to also connect between devices. That creates a lot of RF noise. So please do not ever, ever, ever use that driver. But it is there.
It's not very popular.
And it's just screwing up HF, so don't do it. It gets its power from 5 volt USB. It draws very little current, and you can either use the power supply or one of these USB-A to micro USB cords to actually power the device. It's actually really convenient if you're on a mountaintop or something like that. Just carry one of these to plug into your laptop, and your laptop actually powers the device. There's actually a picture that shows you which way this goes in. If you use the plug the other way and you press hard enough, it will eventually go in. Don't do that. So first step is we need to get into the device. So what you need to do is connect to the device physically, power it up, connect. I would recommend you plug into either port 2 or port 3. It doesn't really matter which one, with your laptop. And then try to get the screen that I show you that is your Winbox screen. So if you go to the Neighbors tab and then hit refresh, after a few seconds, it may take up to about a minute before the device actually comes up. You will see something down here that has a MAC address. The IP address sometimes comes up as 192.168.88, and Mikrotik, sometimes it comes up as 000 for the IP address. Sometimes it comes up with some random number as the thing. It all depends on what the configuration is that you have in there. But once you have in that started up, click on the MAC address. So whether you click on the IP address or the MAC address determines how you actually connect to the device. If you click on the MAC address, then you're going to connect to it using that MAC address, which is what we want to do. And the login will be admin, and the password is blank. And then once you've got that, click connect, and it should take you to the next page. So everybody try that first and make sure that you get logged into the device.
If you don't, raise your hand, we can come help you. You have to actually reset it if you forget the password, if it has a password in it, but I believe that Willem has killed the password on
they
all
should
of these.
all be admin blank. If all else fails, on the bottom of the device there's two buttons. One says mode and one says reset. Nobody should have to do this. But if you have to reset it because either you've forgotten the password or it's a device that you've never seen before, what you do is you press the reset button first, and then power it up while you keep on holding the reset button. It takes about 4 or 5 seconds, and there's actually 2 little lights here on the back. The one says power and the one says USR. When the USR light starts flashing, let go of the reset button. That basically is the hard reset procedure, right? But you shouldn't have to do that. If on the first try you get logged in and you are presented with this screen, click on Remove Configuration after reading the instructions. The instructions actually gives you very good guidelines of what you should do. It says use a strong password, make sure that your software is up to date, make sure that you have a firewall in there, set your country name if you're going to do wireless. Well, we're hams, we don't do that. And set the antenna gain on the wireless interface. Well, we're on max power all the time, so don't worry about that. Okay, everybody sort of getting here? If you just have a blank screen, that's fine. We'll do the reset configuration here in a minute. So if you just get a blank page, where's my reset configuration file? Oh, I deleted that slide. Sorry, I dropped a slide. If you just get a blank page, you don't get this. Go to System and do Reset Configuration.
Microphone on here. If you do not see your router, check to make sure that you have a power light on your router. We've had 2 of them that have had flaky power so far. Go to Neighbors, and then click on the map.
Sorry, there's the page that I was looking for. If you get just a blank page, goes to here, System, and then there's a drop down that says Reset Configuration. Go to that, and in the Reset Configuration, do these 2 things. No default configuration, and do not back up, right? Because we want to wipe out everything that was in there. Don't be patient, just take your hammer. Oh. So you can point out my errors when I get there. Has everybody managed to reset the configuration yet? Are we still working on some? Still a few working. Oh. Oh, okay. What did? No, it'll log back in again. Did you do? So it takes about a minute to actually reboot the system, but then you should basically be kicked back out to this screen.
You have to connect to the MAC address.
Oh, right. So if you had connected through DHCP the first time, then you need to now connect through the MAC address, because the IP address will no longer be there. No, the login name is admin, the password is a blank. You ought not to have to hard reset it, but just cancel, hit cancel, and then hit refresh. Cancels up here. And click on the MAC address again, because sometimes it grabs a different MAC address. The MAC address, not the IP, right? And try to connect again. Connect, not cancel. Okay, now you can do remove configuration. And click on no default and reset, and then and it's going to kick you out again, but hopefully you'll be able to get right back in this time.
I get a whole bunch of MAC addresses. I assume it's the top one?
If your Wi-Fi is probably on. Yes. Probably. Oh, I see what happened here. Which one is the connection to the rest of the world? Do a refresh. Okay, now you know which one you want. Got it. And just do the MAC. You just click on the MAC address and it'll do it.
I'm not sure who I.
Yeah, that's the problem. The password on yours is something different, so other people can't get into yours.
So if you see a whole bunch of MAC addresses, unplug the wire that goes to the rest of the system, so that you only have one wire plugged in, which is your computer, so that you don't see somebody else's router and go and reset their router for them.
Yeah, trying to figure out which one is yours out of that list is going to be a major challenge. So just isolate yourself. You know, our biggest router is at Thornton, and I was sitting at my house one time reconfiguring a new router for Thornton, and I logged into the router, and I was going to clear out the config in it, so I told it reset configuration, no default config, do not back up, and I hit go, and I lost my connections. I was like, what's going on here? Crap! I reset Thornton, and there's about 150 VPN endpoints on that router, and luckily I called him. He's actually physically connected to that router with a microwave, so he was able to get in from his side and reload the config back into that router. And I tell you, it's...
Well, and it's very easy to happen, because you're connected via DHCP to the router, and when you reset the router, the DHCP drop and you fall back to Wi-Fi, which is why I told you go to airplane mode, right? Airplane mode has saved my butt at least once.
DFIU.
Do as I do, or as I say, don't do as I do.
I've been working on Wi-Fi, and and broadband internet stuff since 2001. And I can count on one hand how many times I've had to drive to go fix a problem. I'm telling you, it does happen, but you got to know how to recover from it.
So while the last few people get done here, let me just talk about QuickSet for a minute. So QuickSet is really convenient for certain configurations. So CPE, customer premise equipment, is basically a configuration where it connects via Wi-Fi to the ISP, and your Ethernet ports is your local supply. If you go to the AP, the access point version, then you basically connect to your ISP via the Ethernet port, and one of these Ethernet port is actually labeled Internet. So that's typically the way that you can set it up. Or you can use this as a PTP bridge, point-to-point bridge, which is actually one of those selections also. The problem with QuickSet is that once you've set it once, it typically doesn't like if you go in there and change it and try to set it again, then just weird stuff happens.
If you do it, it may duplicate configs, and because it's built into the operating system, it will let you do things that you shouldn't do, and it will really screw things up. If you happen to quick set it twice, you probably should reset the device to default and start over.
So here's just an example of what this looks like. So this is actually set up for CPE. So what it will do is it will immediately start searching all of the Wi-Fi that's out there. So here I happen to pick Houston, and it basically shows me the signal strength. It shows you the network name down here, and then if you add the Wi-Fi password and hit connect, it will actually connect to that particular link. Over here, you want to set it to router so that you're actually setting this up as a router as opposed to a bridge. We'll talk about the difference later. Typically set the address to automatic so that it will pick up an address through DHCP. That we typically don't worry about, but now you have to pick a local subnet. So in this case, I set it to 192.168.3, and then the net mask is a /24, so I set the router 2.1. You can enable a DHCP server. You can enable native address translation. You will bridge all the LAN ports. You set the password for the admin user right here. Very important. Set your admin password there. And then you can give the router an identity. So, you can basically set up the whole thing there, and once you click OK, it'll configure that for you.
Let me put on my KC2VJW hat for a second. If you don't put a password on this router and it is connected to your home internet, and that home internet has a real WAN connection to where it's routable to the world, within a few minutes, somebody is going to be in your router trying to turn it into a bot. Always, always, always put a password on that thing so that you at least have enough time to configure the router, and not 1, 2, 3, 4, and not password or passworm or something. Make it something a little harder to get.
If your password is password, please make the P uppercase.
Yes.
I can add something to that. So if you go to any of the MOM
What's a mom?
presentation, a Mikrotik user meeting. Look, So if you go to, hello.
You won't hear yourself.
Okay, so if you go to the MUM, every once in a while Mikrotik will give a presentation on exploits, because Mikrotik has been infamous in the broader word about exploits. And the first thing they explain to you is that every single networking software company, Cisco, everybody else, has got exploits. The second thing they say is that no device with a default config has ever been hacked because the firewall is set up. However, the one thing that everyone fails to do is change the password on the default config before they put it on the internet.
So everybody knows that
#1
password.
vector.
Everybody
Because it's
knows
admin
that
and blank.
password. Yes.
Right? So the first thing I do on on all of my Mikrotiks, even if they're not going to the internet, is I go in and create a new full access user with a different username, and then log in with that username and delete the admin account.
You can actually delete the admin account without re-logging in, and you can get into trouble. So just be careful.
No, I think they used to, but you can't. If you log into this admin, they don't like delete admin now. But they used to be able to do that.
Yes.
So, word to the wise: change your default logins.
Yes.
So the next thing, hopefully everybody is in. we're going to do is we're going to do two things. We're going to do what we said. We're going to change the system password, and we're going to change the system identity. So system identity is on the left-hand side. You'll see all of the drop-downs. System is where we do most of the system settings. Everything in that menu that you get after system is in alphabetical order. So learn the alphabet. It is very useful. System identity, you can make it whatever you want, but use your call sign, right? Because we all have different call signs. And make a note on your worksheet what your system identity is. Also, don't forget to write your name at the top of your worksheet, because that's what we're going to use for the test. That is at the end of this class.
What do you need? Not connecting?
Okay, we'll come back to that in a second. Let me just finish this. So make sure that you set your system identity. And the key thing about it is if you look at the top of your Winbox, it will actually show you how you're connected to the device. So it shows you your username and whether you're connected to the MAC address or the IP address. And then it gives you the name of that system, right? So always verify that you're in the right system at all times. And then if you do system password, you can change the password so that you can do something unique so that you don't accidentally log into somebody else's router or somebody else logs into your router. Yeah, let's just stick with admin for now. You can add a new user, but that's more trouble than it's worth. The old password is blank. Just leave the old password blank. Next, it will be 2 more slides. Are you in the quick set? Are you in the quick set? Don't use the quick set. So now we have a unique name for our router, and we're not going to log into the wrong router. Now we're going to actually start the configuration. So the first thing we're going to do is just rename the interfaces. So up here, there's a thing that says interfaces. If you click on that, you get this interface list. And the interface list will show you all the default names. So you should see Ether 1, 2, and 3, WLAN, which is grayed out, and Powerline. So what you want to do is to change the names of those Ethernet ports to how you're going to use them. So Ether 1, we're going to call the WAN, right? Just because that's how it's labeled, although it could be any of the ports. So click on Ether 1, you'll get a screen that looks like this, and you just type in here whatever you want it to be. So just change it to Ether 1 WAN, and then Ether 2 and Ether 3, you can call whatever you want, but I typically would call them just LAN if it's just a general purpose port. If it was a device such as one of these big ones, and you want to label, this is where the DMR repeater is, this is where everything else is, you can label them whichever the way you want. But I would just recommend that you label both Ether 2 and Ether 3 as LAN.
Now, let me make a note here. I know some people that will go in and they will blow away the Ether 1 and type in LAN. If you don't leave the Ether port number in there, you got devices that have 24 ports in there, and if it just says LAN, okay, which one is it? So always leave yourself or somebody that comes behind you some information as to which port it actually is. So do something like Willem says, Ether 1-WAN. Right. Don't kill the Ether 1, whatever you do.
It's the name of the Ether port and its function, or
you
what
can
it's
find
connected
it,
to.
But it's another level down. You have to click on a button to get to it.
I also recommend that if you have more than 9
Yes.
If you have more than 9 ports on your device, use 2 digits. So for things less than 10, use 01, 02, 03, etc. It'll make your life easier.
All three. Ether 1 should be WAN, Ether 2 and 3 should be LAN. So local area network, wide area network. And the other thing that you'll notice is this power line 1 may be on yours. Highlight it and click the X. Clicking the X disables it.
Clicking the minus deletes it, but you can't delete a hardware port.
So you want to disable the power line because it just generates RF noise in the HF band.
It's a moral victory.
Very well put.
If it's gray, it's off.
Okay, is everybody there? Because we're getting to an extremely important step now. So what we're going to add next is the bridge. The bridge is the most important thing in the router. Think of the bridge as like a bus, right? And everything is going to connect to that bus. The bridge is also how the router is going to identify itself. So we're going to associate an address with the bridge so that we want to say, I am now talking to the router. We will actually talk to the bridge itself. The reason why you want to associate the address of the router with the bridge is the bridge will never go down. The bridge will always be up. You can associate an IP address, for example, with an Ethernet port. But if there is not a cable plugged into that Ethernet port, the address goes away, right? So if you associate the address that you want to talk to the router with that Ethernet port, and suddenly somebody just unplugs it, you can no longer talk to the router. So you always want to use the bridge as the thing that you're going to identify the device by. So how you add a bridge is you go to the button here that's labeled bridge. You click plus, and all the defaults are OK. You just click OK, and now you have a bridge.
Anybody not there?
If you have bridge and bridge 1, you didn't properly reset your configuration at the beginning. Can you help Jerry, John? Can you help Jerry, because he's got 2 bridges. Ben. So can you help him catch up real fast? So the next thing we're then going to do is to map the ports to the bridge. Now, here's where we make a distinction between bridging and routing. Bridging essentially means you can talk to everybody on that bridge, right? Anything that goes into the bridge comes back out of the bridge. So if you are mapping ports to the bridge, those are the ports that are going to be local to this device. So if you have a big router like this that's going to be on the site, typically what we would reserve is 2 or 4 ports to connect to the rest of the world, and everything else goes on the bridge. With this little device, it's easy because there's only 3 of them. This can be very tedious. So this we actually do through the command line, because you can go up arrow Ether 4, Ether 5, Ether 6, Ether 7. You can click, if you're a fast clicker, you can do that too. If I have to type it, so what we're going to do is we're going to add ports 2 and 3 to the bridge. We're not going to add Ether 1 because Ether 1 is going to be a routed port, right? So the difference between a bridge port and a routed port is that the bridge port is local. The routed port is going to connect to something else, right? So what we need to do is add 2 ports, Ether 2 and Ether 3, which in my case I call DMR and LAN, but in your case it's probably both called LAN. We're going to add them to the bridge by, in the bridge script, if you're not there, go back to bridge, and then click on the tab that says ports. And then click the plus, which will give you this dialog. It'll default to bridge 1, but for the interface, add the 2 bridges. Do not add either Ether 1, the WAN, or the WLAN to it. No. Okay. And so what you should see, if you've done this right, you'll see there's Ether 2 and Ether 3 in the WAN. This is just messing around, so don't worry about what that says. But that's what it needs to look out like. You'll see next to the bridges, you'll see the letter H.
Yeah, there's one comment.
Sorry.
So when you guys are configuring the bridges on your device, when you add the port that your computer is plugged into on the device, it's going to drop you. It just will do that. That's just the way Mikrotik works.
Right.
You'll have to reconnect. Just make sure you do that. Yeah.
Yes. It should keep your, click on the keep password up there so it doesn't delete it every time. So try to connect now. Just give it blank to see if it never took. You may have to do a hard reset on it if you can't get back in that way.
If you look at the list and you see 2 bridge
plugged
1s,
into it.
Okay, so
if you look to the left of that,
Right.
you'll see the port name.
Yeah.
One will be Ether 2 and one will be Ether 3.
Excuse me? At the bottom.
Bridge
On the
1,
orange.
bridge 1, and then
Down
Ether
there.
2 and Ether 3 will show up in the list under it. Yours looks just
So
like this.
you have to unplug it first, hit reset.
Yours just doesn't have a name on the port, but they look just like that.
Hang on a second, she said this.
Yours looks just
Yes,
like
unplug
this.
the power, but before you do it, Greg may have a solution.
Nope, you're right where we are.
So if we're all there, now is where we actually start doing something IP. So here you need to look at your worksheet and figure out what is the address, the bridge address that you are going to associate with this device. So it'll be 10.99. Something or the other .1.
Why did we pick 1099? Because it's not used in our network and we don't want to blow anything up.
thought it had something to do with the IRS.
That too.
Damn, I should have thought about that. Okay, so the important thing is that, if you have a larger device, should you add all of the desired LAN ports to the bridge? Yes, good question. So if you have a big port, device like this, typically what you're going to do is reserve the first few addresses for all of your WAN connections, right? So typically,
Kevin, this is perfect for you on the western slope. You're going to have link radios that are connected to your network. Those link radios are not going to be on the bridge. They are going to be routed ports. Those ports should not, under any circumstances, be added to a bridge. Only your local devices like computers, repeaters, power switches, whatever they happen to be, those are local site devices, and those would be connected to the bridge. Does that make sense? Did that answer your question online?
so this is the device we typically deploy on mountaintops. It has 10 ports on it. These are gigabit ports. These are fast Ethernet ports. And our microwave links are typically not gigabit. So this also has PoE out. So this may be where you want to connect your radios. And then these would be your local on-site ports. By labeling them -LAN, you know what you are going to use that port for. You can use it whichever the way you want, but if you actually put it in the config, the next person is going to know what the heck you did.
We have a lot of people that touch our routers. There's folks in 3 states touching these things, and if we don't leave snail trails, it's really hard to figure out what somebody did.
So now we're going to associate an IP address with the bridge, right? So what you're going to do is go to IP addresses, and there should be blank. We don't have any IP addresses in this device yet. So you're going to click the plus and then say, now we're going to add an IP address. The IP address is the one on your worksheet. It's 10.99.some number.1/24. So by adding the /24 in the address, you can skip the network part. You don't have to specifically specify the network address. But it's basically going to give you 256 addresses that you can use on that device. And then the interface needs to be bridge 1, right? So this is, you're associating this address, but also implying an entire subnet that is going to be mapped to the bridge.
As soon as you click save on that, it's going to calculate the network address in that box below it. You do not have to touch that. It will. Let me take a look.
If you do apply, it doesn't
0.
go away. If you click
No,
OK, it
hold
takes
on.
it
10,
and goes.
99, 16,
Just click OK.
1.
Apply is if you just want the dialog to stay up. If you are very confident in what you do, click OK and go on to the next step without checking if this one worked. Oh, no, it's instantaneous. Yep. So does everybody have their bridge addresses set? You only do it once.
Yeah, you can put as many bridges
The
in there as
next
you
thing
want.
we're now going to do is to set a second IP address. That's the IP address that's going to allow you to talk to this device right here, right? Through the wiring that you've connected with.
So Darren just had a very good question. If you've got a big device like this, is there any reason why we can't set up multiple bridges? Absolutely not. You can set up as many bridges as you want. For example, if you had 2 clubs and you wanted to give a different club a different set of IP addresses, you could break this off into multiple sides. I mean, there's random. You can make any port any bridge. So you could tell them that, okay, these 8 number of ports here, is going to be for NCARC. These ports would be for RMHAM. Whatever it happens to be, it doesn't matter. And you can assign IP addresses however you want. It doesn't matter what IP address goes on what bridge, just as long as you know what IP addresses are out there.
So for example, at my office, the way I have it set up is the first 8 ports are WAN ports. The next 8 ports are DMZ, demilitarized zone, right? Web servers and all of those kinds of things go there. The last 8 is LAN, right? So anything that you can access from the internet goes into this separate DMZ bridge, and the addresses and the firewall is set up to let certain things into there, but not let it into the LAN, things like that. So
Mike has a question.
About some of the bigger switches and routers, there's switch chips built into these things, and when you create a bridge, some of the ports can be set up, can be enabled and are able by default to be hardware accelerated. Most of the devices, and you can check the specs on this, most of the devices can only hardware accelerate one bridge. If you create 2 bridges, the second bridge that gets created is not hardware accelerated on the chip. So just be aware of that.
There's no switch chip in this router. This
just hang
router,
on to it.
everything that would be in a bridge on this router would be hardware separate. I mean, this is going to be completely software bridged if you did it. It's going to be slow. These are designed to allow each port to be routed. These are very fast in routing, but very slow in bridging. Now, you get this device, which is a very inexpensive device. It's got 24 ports of switch chip. It's very fast in switching and very slow in routing. You can use it, but you're going to be sacrificing something.
Right device for the right thing.
A switch chip speeds up switching, but it does not work for bridge or for a switch chip does not work for routing. The routing is done by processor.
So if you're copying stuff locally, but you're not going out to the internet, having the hardware acceleration works for that. It doesn't make it faster if you connect to anything else. It's that H that's next to the port in the bridge. If it says H, it's hardware accelerated.
If you connect to your router and you go to bridge, you would have an H right next to R.
It's this H
The
right
R
here.
for running, it'll have an RH if it's got a switch chip. You have a bridge chip.
So the next thing that we want to do is now actually connect to the rest of the world. So to do that, we need to assign an address on the WAN port. Again, look at your worksheet, what your WAN port address is, right? So the bridge address that we said before is what the router calls itself. The WAN port is what the rest of the world calls that router.
Tristan Honscheid says you can also use a single bridge in a partition, and partition ports by VLAN tagging.
Right.
That is not Router OS 101. That's probably closer to 501. So
yeah. If you have a question with us, email nm0th.
That's a brand new call, by the way, as of last Tuesday.
Oh, really?
Yeah.
Oh, okay. So again, you're in the address list. Just click plus again, but now set the IP address that is your particular one. Don't use .7 because that's what I'm using. Use whatever your address is, 10.99.1. something else.
/24.
No, it's on your sheet. It says WAN address. Why do you have a blank one?
You want to add? He's
No, it
adding an
says right
address
there,
here.
WAN
So
IP address.
address.
You're in lab 1, not lab 2.
Address.
Always /24, yes. And make sure that you set the interface to Ether1 WAN or whatever you call the WAN port. Slash 24. Everything is slash 24. So if you just do slash 24 there and you leave the network blank, that should work. If all went well, you should now be able to ping 10.99.1.1, which is this device right here. So how you do that is you click Tools, Ping, and enter 10.99.1.1 and click Start.
Right, so if you're connected, or you think you have your IP address correct, on the left-hand side, look for the word Tools in Winbox, and click on the word Ping under there. And then type in on the ping to
No, you're
Ping
adding it to the
to
bridge. Cancel.
10.99.1.1
IP addresses.
and then click Start.
Just minimize it.
It should
Just keep
look
the
like
minus.
this down below it, and you should get a response with a millisecond
So do
indication.
IP addresses.
If it says timeout, you did something wrong.
Addresses.
Not
So
ping flood.
Click plus again.
Not ping flood. Ping flood is bad right now.
And
We
put
got a
in
lot of people hammering on this poor
that
device up
address.
here, and ping flood would be bad. Everybody got it except Lisa. You want to see if you can help her fix that? You're a little past.
24. Okay. Okay, and now do Tools, Ping, alphabetical,
Yeah, Winset.
and put in 10.99.1.1 and click Start. So something's wrong because you can't talk to it. So let's see what's wrong. Oh, are you plugged in? You have to plug into the rest of the network first. Port 1. Yes.
So one of the things that you guys are starting to see as part of this is there is a lot of configurability to a Mikrotik device. Hey Doug, what do you say about flexibility? Flexibility paves the road to futility. And one of the things that you'll find out as part of the Mikrotik world is you can really paint yourself into a corner very quick with the functionality of these devices. You can really get caught, but it's extremely flexible from the standpoint that you could pretty much make it do anything you want. You could pay for what this device can do for 15 bucks. It could cost you many thousands of dollars in the Cisco world, with extra add-ons and other pieces of hardware and software licenses and everything needed to do what this device will do. Yes. So Steve K0 IBM just commented that for what the software maintenance is on a Cisco device per year will buy you the equivalent Mikrotik device. That's very true, absolutely.
So who has been able to ping 8.8.8.8? If not you. If you can ping 8.8.8.8, something's wrong. Because we have not told the device
How to get there.
how to get to 8.8.8.8. Right? So it knows how to get to 10.99.1.1 because the WAN port you said is a /24, right? And
you help Tim right behind you?
10.99.1.1 is inside that 24. 8.8.8.8 is not. So how are you going to tell it to get to 8.8.8.8? Well, you have to explain it to it by adding a route. And the first route we're going to add is the default route. If you don't know what to do, send it to that guy, right? So that is done by doing IP routes, and you'll see that there are two routes that are already there, right? And they say DAC. They're dynamic, they're active, and they are physically connected to this device.
Those little letters mean something, and they're very valuable information. D, dynamic, is anything
slide.
that's automatically generated by the router.
That's the next slide.
Oh, okay. I'm skipping ahead.
So what we're going to do, the destination address 0.0.0.0/0 is the widest net that you can cast.
It's everything.
So that happens to come out as the default, so just leave that alone. Then you need to set the gateway. What is the IP address that you send stuff to if you don't know where else to send it?
It's the next hop.
10.99.1.1, which is this device
It's this
over
device
here.
right here, 1099.11. This is the default gateway.
And then to check that you can connect to it, set it to ping. You can either say connected or ping, it doesn't really matter, but ping is useful if it's not a physical wire that runs end to end, but it goes like over a microwave bridge or something like that. It'll basically try to talk to that IP address. So that's how it's going to know whether it's connected. Once you've done that, click OK, and now try to ping 8.8.8.8.
Also, there's another little thing here. If you look at your route list, IP routes, if it's black, it can see it. If it's blue, it can't see it. So blue tells you that you cannot get to where you're supposed to be.
Click forward and talk about the
Route flags are a very important diagnostic tool with Mikrotik. And if it's an active, it's got an A next to it. If it's not active, it'll be blue. Jerry Vilhauer over here needs somebody that knows Mikrotik. He's got a confused look on his face. S is a static route that you add. If you look in the device with the route you just added,
okay.
it'll be an AS
IP routes.
next to the default gateway that we
Click
just
the
added.
plus.
C is connected, which means it's
So
physically,
default
the port is up.
destination address is good. The gateway needs to
Dynamic
be
is anything that router
10.99.1.1.
OS adds itself. So you'll see DAC on stuff that the router added because it knows about that
gateway
subnet.
should
So
be
your
pink.
local addresses, 1099.x.something,
click
will
on
show up
check
in that
gateway.
list with a DAC.
And make the window wider. 'cause
That's
you're messing
very
buttons.
important information when you're trying to diagnose what's going on.
Okay.
Everybody up on the routes?
Now
Where they
try
need to
ping
be?
8.8.8.8. John,
Slightly different.
back up to the previous slide. Thank you. Just leave that up.
Okay, we're going to leave the default route thing up here for the people to try to get to that. Ed James, are the New Mexicans up where
You
we are?
In
Adding a new route? Yeah.
so the destination right is correct. Right now you need to tell it what's the gateway. The gateway is going
It's
to be
a little bit- there is here.
99.1.1. It's not on this page.
Ed James, do you have audio in New
And
Mexico?
check gateway is going to be ping. And then make the window wider. You're missing buttons on the, there you go. Click OK.
Can you guys in New Mexico wave? There we go. Just so you guys know, there's a bunch of folks sitting in a room in New Mexico duplicating what we're doing here.
So for this particular one, there's a couple of tricks. First of all, make sure that your window is wide enough so that you can see the buttons on the right-hand side here. Otherwise, the buttons are missing. And everybody is using the same gateway, 10.99.1.1. It's not on your worksheet. Yes. Everybody passed this step. So the next thing we're going to do is to add DNS. We actually don't need DNS for our routing here, but when the next step is we're going to actually have your laptop cruise the web, and it's going to need DNS. So we're going to go IP DNS. Again, it's alphabetical, so D, before C and after E. And then set the server to 8.8.8.8, which is Google's DNS. Oh, yeah. Okay. That should be pretty straightforward. We don't really have a way of testing it, so we're going to just have to trust that it works. It'll be 3 more steps before we test it. You can have as many as you want. The down triangle gives you more.
Do we want to take a break?
And just after DHCP.
Okay.
Okay, everybody there? Okay, now this is the only time that we're ever going to use a wizard, right? What the wizard will allow us to do is to set up DHCP so that we can make, right so far, the router can talk to the rest of the world. We now need to teach the router to make everything else talk to the rest of the world. So
if you don't use the DHCP setup button, you will miss something and it will not work correctly. This is the only time.
well, Ben and I know how to do it.
Yes.
So go IP DHCP server. There's a client and a server, right? We're doing the server. And then do DHCP setup. And the wizard will actually figure out the right things automatically. The only thing that you need to change is make sure that the DHCP server interface is the bridge, not any of the other ports. So if you set that to the bridge, all of the rest of the stuff should just give you the correct defaults till you get to the OK at the end.
So Rob Coulter in Durango says, I'm getting lost on routing, but he won't pop up on the audio and ask.
Oh. We'll cover more routing in the second lab. So if you're struggling with routing, don't worry about it right now. If your DHCP worked, go to your laptop's interface and switch it to DHCP, right? So ask it to ask the router for IP address. Yes. It should actually default to DHCP, so it may already be doing that. And as soon as you're there, try 2 things. Connect back to Winbox and ping those two addresses. And what Winbox should be able to do is to ping those two addresses. Then try to do the same thing from your laptop. And you should be able to ping 10.99.1.1, but not 8.8.8.8. I'm going to do that NAT, and then we'll do the break. So that would depend on your computer, but typically it's just however you normally, the easiest way may be unplug the Ethernet cord from your computer, wait 10 seconds and plug it back in again, and it will probably do DHCP. If you just unplug it and wait 10 seconds and then plug it back in again, it'll probably do DHCP.
Can you look over my shoulder just for a second?
Sure. Okay.
And
So you've got the bridge IP. Now you need to add the WAN IP. So plus again. Put in from for your lab your WAN IP 1099.122. 22/24.
Doing personalized support to the
22/24.
folks online via text message.
Click OK. And
that's probably what I was missing.
right. So that should be fine. So try to ping 10.99.1.1 from here. No, it's not finding the route. Are you physically plugged in? Oh, yeah, you need to physically be connected.
You should be able to, if your DHCP is working correctly.
Now you need to do, so
You may
which port
need
did
to
you call
release
WAN?
and renew your address. The best way to do that is unplug your
So
Ethernet cable
that
and
needs to
plug
go
it
in
back
one.
in.
That WAN?
Yes, right, this is your WAN wire.
Correct.
And then that needs to go in there.
Yes, sir.
It actually gives it starts at the bottom. So, really?
Got 254.
Oh, yeah, that is the top, isn't it? Oh, you wanted to start? I don't think it had, well, you can do static
Command
assignments, right?
Just the command
But
prompt.
it's just, yep. So is anybody able to actually ping 8.8.8.8 from their laptop? You messed something up if you did that. Because if you, let's say your laptop has an address of 10.99.27.254, and you ping 8.8.8, 8.8.8 is going to say, who the hell are you? I've never heard of you, right? What you need to do is you need to add NAT, right? Because your local address that your laptop is getting from the router is not known to the rest of the world. So what you need to do is to go to IP Firewall Nat. Under the General tab, say do source NAT, right? Source NAT is NAT. So you're basically going to have your router pretend to be your laptop by doing native address translation. And the out interface needs to be your WAN interface. And then you go to the Actions tab and set it to masquerade. What that does is every time that you try to ping 8.8.8.8, What the router does is it
Nothing.
says, oh, this is
I just
actually
checked
coming
all the
from the
config and
laptop.
it's good.
I'm going to pretend to be the laptop to the rest of the world, and then you can connect to 8.8.8.
Google.
And when the packet comes back, it says, oh, this wasn't me, this was actually the laptop.
Nothing.
I'm going to translate it back so that I can talk to the laptop. You want to explain it better? Because
No,
that's
you
as
did
best I
good.
can do.
So NAT is a very interesting thing. NAT allows your computer to be filtered to the internet through the router, and it saves IP addresses out there. With the new IPv6, which this is not
Okay,
designed
so-
to do,
Okay, so that means
you don't really need to worry about
you're
it.
not on DHCP.
We're using IPv4. You talk to the world as one
Well,
address, and
let's
the
just do
router
it again and give
decides
it a
which
few seconds
computer
longer.
inside on the network that traffic came from and comes
And
back
you-
to.
the DHCP is
That's
running,
why
right?
it works as a quasi-firewall, because if the router is set up correctly, it will stop all inbound traffic at the router. But
So do,
you have to do
IP
some other things to this router to make
you
it more
get the
robust.
IP
Do
address
not
on
put this
Windows?
device
Is it
on a router
IP
without
config?
some type of firewall.
IF config.
Talk to Dr.
I just
Schroeder
want to see what is
if you need help with firewall, and
IP.
we can get you set up
Just
with
type
that if
IP
you want
config.
to do it. It can be very
Okay.
tricky. Firewalls are a
Scroll
very
back up.
difficult
you
thing.
Got you got
And if
an
you put a
address.
firewall
so
in the
try
wrong
pinging
way, you
now.
will
I
lock
think it's
yourself
gonna work
out.
now.
Yeah, it's W0GV lowercase. Somebody got into his router and changed it.
Yep.
Try admin and blank. That didn't work.
Try, so hit
Somebody got
Control-C,
into his
do
router. We're going to have to give him a
10.99,
different router and reconfig it.
10.99, where's your worksheet? 10.99.17.1.
Try admin and W0GV.
Ping, ping,
Lowercase.
just do up arrow.
I confirm that's what was in there. Try it in uppercase.
10.99. So
Gonna have to
there's
we're
something
gonna have
wrong
to
with
give
the
him another
config.
router
Let's
and
go back
reconfig
to
it.
Winbox. Just leave that.
There we go.
The NAT rule.
Winbox.
Reconnect.
Okay, chain
Go to
is source
IP
source NAT.
addresses.
The out interface
Okay.
is Ether1
We
WAN,
can do IP routes.
and under the action tab, the
routes.
action is masquerade.
So do tool ping.
Nothing on the out interface at all. That should be clear and it should be gray.
Try 8.8.8.8. It's bold. Okay.
Tried that one and I couldn't get.
So that works. Okay, so I think go to. So what I just did here during the break is I went around and filled out for lab 2 the WAN IP address, the partner gateway, and the partner, the frequency. What I haven't figured out is an SSID. And I haven't given you your partner's BridgeNet address. So what we're going to do here is this. In order to have the two radios talk to each other, in microwave, they use something called the SSID, right? The whatever SSID stands for. Thank you. Right? ID part I figured out. These devices are not international versions. If they were international versions, we could actually use the ham bands to do this. If we use the ham bands, we put our call sign in the SSID, because that way we are FCC legal at all times, because every packet is going to have your call sign in it, right? But what we're going to do today is just use the ISM band, because there's not that many of us. So the frequency that we've set there is basically, it should be unique for everybody. You and your partner need to agree on an SSID. And what I would recommend is that you pick the call sign of the person for which the WLAN IP address ends in 1. So fill in for the SSID the same call sign for you and your partner. And if you want, you can add -5 or -7 or whatever to it. It just needs to be unique. We've got an odd number of people. I don't know who to partner him with. Well, don't. Which ones are blank? So you have 15, you have 14. What do you have? Okay, so if the third octet is 14, so sorry, Dick, you need to go. Oh, crap. Sorry, Dave, I gave you this. So ignore the top part here. Scott, you just use that. Okay, so you and Dick are going to work together. Yes. What? Oh, I didn't assign you with somebody.
I'm looking.
Oh, no, okay, right. Sorry. Counting by twos is really hard for a computer scientist. What's the octet that I gave you guys? 17, 18, whatever. Use 23 for the third octet. Sorry. Don't know. Right, so the partner bridge net is going to be, you need to figure out what is the net for the bridge that your partner has, right? So your address is obviously what this is. You need to figure out what the bridge net address is of your partner, right? And it is not .1. Notice that it says it's 10.99.something.0/24. It is the subnet of your partner, not the bridge address, right? Do you understand the difference between his bridge address and his bridge subnet? The subnet ends in .0, which means it's all of the addresses within that range. .1 is specifically the router. So did everybody get their lab filled out? Yes, and right. So here's where things get really exciting. We're now going to actually set up something similar to what you would do if you had one of these, right? In order to configure these microwave radios, you need to give it an SSID and a frequency, right? So that's what we're going to configure next. So go to wireless, and under wireless, under the wireless interfaces tab, notice that WLAN 1 is there. So click on that. Don't turn it on yet. Just click on it. And we now need to start configuring the microwave part. And this is the same whether you're using this device or that 2-watt long-range radio over there or any other microwave device. The first thing you're going to do is to say, we're not wimps. We want the advanced mode. Go to wireless, which will give you this wireless tables. Then click on wireless on the blue line here, WLAN 1, and it'll give you this particular window, and you need to go to the wireless tab, not the general tab, the wireless tab. It'll come up in the general tab. And then click the advanced button. Yes.
Okay, the next thing we want to do is there is a pull down under frequency mode partway down the page. If you hit advanced, if you did not hit advanced, you will not see this. So make sure you have hit advanced. Under frequency mode, pull down that list and look for the word super channel. Super channel is how you get a Mikrotik device to go out of the standard ISM and UNII bands into the ham bands. Kevin, this is something that you guys will want to do for sure, and this is something that the Ubiquity hardware does not do ever. When you purchase Mikrotik hardware, we purchase it in the international version. The international version gives us the ability to pick any frequency. And yes, you can get in trouble if you don't know what the ham band is.
Who does the...
Make sure you have your band plan for microwave and know how wide your channel width is. Most of the time in this hardware, it's going to default to a 20 megahertz channel. That means your center channel is 10 meg above and 10 meg below. So if you went to the top end of the 5 gig band,
Just a second.
and
Can
you
just
set
show
your
the international in
radio
the box?
at
Put it on the screen.
5920, you're going to be 5 megahertz outside the ham band with your emissions.
click it.
That would be a big no-no.
There you go.
You cannot go any higher than 5915 with a 20 megahertz channel because the top end of the ham band is 5925. Always know where your band skirts are. Yes, you can get in trouble with this.
And your call sign is on the packet.
If you put your call sign on the packets, the feds know where to come looking for you. Trust me.
The country is actually not that important, but we typically put it on no country set, which is basically the international version.
When
right?
you're on Super Channel, yes. Somebody standing on the wire? Do you have IP?
Not my problem. I still see Larry Olson nodding his head on this laptop, so we didn't lose everything.
We're not feeding it, but everybody else is still in the meeting.
Recording in progress.
Okay, minor little oops there. We lost internet connection somehow. With the configuration on Super Channel, the international version will give you the ability to put this radio wherever you need it. The ham band is exclusive at 5840 to 5925. You can still use the commercial channels. And for you guys out in the hinterlands, this is probably okay. I know that here in town, if we were on a commercial
We are
channel,
not getting any audio? No audio?
hang on.
We would get straight.
No audio here in New Mexico, at my place either, Bill.
Say if you guys can hear us, say so.
I can hear you now.
I can
Okay,
hear you now here at my place, KHMW.
Thank you.
minor little glitch this morning. If you're using Super Channel, you can still put these on commercial channels, but realize that it's going to cut your usable distance for your paths by probably 80%. I'm serious. We have paths now going 60 plus miles with no problem on a pair of 2-foot dishes in the high -40 dBm area. We've got hundreds of megabits across these links at 80 miles. If you're on a commercial channel, that could be a 15-mile path, and you're lucky to get 60 megabits across it. You can still use it. When you stack up all of these 20 megahertz channels next to each other, you can usually squeeze 5 channels in the ham portion of the band with a little bit of overlap into the commercial. We have sites that have 8, 9, and 10 paths out of them, so we have to use commercial channels on some of these. So pick your shorter shots and put them on commercial channels. Like if you look at Horsetooth, Horsetooth happens to have about 9 paths in and out of there. Some of that stuff is on commercial. Fremont Peak, there's 11 paths out of there. We only have 5 channels that are next to each other. So things are getting reused a lot of times as much as possible, and we are using commercial stuff for the shorter shots. And they do get interfered with. Just realize that the long shots that you have need to be on ham channels.
Of course, the SSID should allow you, in theory, to put 2 things on the same channel, but don't do it.
Yeah, if you put multiple things on the same channel, they will step on each other. It is still radio, and they are still using that same transmission method, and they will talk to each other. Not always a good thing.
So the next step is then, once you've changed that to super channel, if you actually look at the frequency list, you'll see you now have a ridiculous number of frequencies, right? It starts at like 22, 23 something and goes way up. This device actually will not do all of those frequencies because it is a US version little router. But if you buy the international version, then you can actually use all of those frequencies. So it'll let you set it, but it won't actually turn on. So just pick the frequency that I gave you there. Now, the next thing that we're going to do is to set up pairs, right? And the pairs are different from the transmit side than the receive side, right? So in a point-to-point link, the one side acts as the access point, and in microwave parlance, that's called the bridge. The other side is the client, which is called a station bridge. So the .1 person, all of the .1 persons, raise your hand. This is your configuration. The .2 people don't do this configuration. So
when they say .1, they're
the
talking
.1
about
person.
your
Mode is bridge. Frequency is whatever the frequency on your worksheet is. SSID
Station
is
bridge
whatever
is the
the
other side.
SSID you have. And your scan list will say default. You need to physically type in that frequency if you want the scan list to read the same as the frequency.
And it will not work if you do not type that in. If it says default, it is not going to work. Now, when you guys can't make this work and you're wondering why, and it still says default in there, you didn't listen to what we just said.
Now, the wireless protocol for what we're doing here really doesn't matter. But get used to putting in end stream. What end stream is, it's a modification of the 802.11 B and G and those protocols that work with long-range wireless connections. The problem is the time of flight that you start getting on some of these long paths are such that the 802.11 protocol times out.
If you're past 33 miles, 802.11 will not work.
It just takes physically too long at the speed of light to get to the far end and get back. So end stream is a Mikrotik variation of 802.11 that allows you to run much longer paths. So set the wireless protocol to end stream. Okay.
Advanced.
everybody, all the .1 satisfied with what this is here?
You'll have a button that says advanced where simple mode is. Okay, if you don't have the right fields, there's a button here that says simple mode, and it'll say advanced when you click. If you click on it, that's your advanced mode, and the fields will come up that you're missing.
The client side looks almost exactly the same, except the mode is going to be station bridge. So all your .2 people, this is your configuration. Station bridge, same frequency, same SSID, same scanless frequency, protocol and stream.
Kevin, Milner, one of the things that you're going to find on the Western Slope when you start to install this hardware is that some of your paths are pretty long. NStream will help you work through those paths by making sure that there's a sliding window so that it's not out of the timing on these radios. If you use 802.11 and you go over, I think the magic number is 33 miles. They will not actually lock up. You may see signal and it may connect, but you actually won't be able to pass data properly. If you go to NStream, that distance doesn't matter. We have paths out to 80 miles and they still work.
I did have a question here. It was asking about the security profile. And we got to remember that we can't do encryption with amateur radio. So on the scan profile, when we're using the ham frequencies, just keep in mind that we're not using any.
I have a slide somewhere that says it. Oh, there it says, on the access point, right? No encryption in the ham bands.
If you're using commercial, I encourage you to use encryption. If you're using ham bands, do not use encryption. There are multiple ways to keep people out of your channel. MAC address filtering is one of them, but that's not a 100 level type situation.
If your connection was, if you did the last two steps correctly, go to the tab that says registration. You should now be registered between your two radios.
That's good. We hear people that are registered. That's a good thing.
Anybody still struggling with getting registration? You're talking to somebody. We'll establish who that is. Did you guys? You're still working on getting it up? He's still working on his configuration.
Where do you put these IP addresses?
You don't have to put IP addresses yet. All we're doing is the RF configuration. We'll do the IP.
2432. He's WB0EVA 22.
Right.
And I put it on.
Go to your scan list and put your scan list. Type in on the scan list your frequency. You have to type it in. Just start typing. It'll overwrite.
Oh, okay. 432.
And the protocol should be NStream. Hit apply. Okay, you should be good now. Look at your registration.
Where's that?
So, wireless registration. No, go to wireless registration. Nope. Just make sure that you guys have both the same thing.
Problem is he didn't do on the very beginning, didn't do the total default. This was managed by some.
Oh, go to CapsMan and try and kill it.
Here's a wireless wire. This is gigabit, 60 gigahertz. They'll go to about 350 meters.
Who's having trouble? Yes. Depending on the bandwidth. Yeah.
This is 1,500 meters. That's 350 meters at 60 gigahertz. This is 1,500 meters at 60 gigahertz. It's 60 gig.
Oh, you need to be station bridge.
It's license free.
Okay.
Just like all of the stuff that we've been playing with today. And they are extraordinarily robust for being at 60 gigahertz. If you guys know, 60 gig is water absorption frequency. So when it starts to rain, these things fade badly.
Some of these will come with a 5 gigahertz failover channel.
Yeah, see, it says managed by Capsman. So we need to go up here to Capsman and see if we can kill it.
Sure, I'll give these away. I don't own them.
1,500 meters.
You could do that.
That's worth
Ubiquity
trying. It'll let you delete it.
makes 60 gigahertz radios that have 5 gigahertz failover radios in them, so that when they fade, they'll switch to 5 gigahertz. Some of the Mikrotiks do too, but they're significantly more expensive. These are $275 for a pair of radios that come out of the box linked. They just work. These will go 1,500 meters, and I can guarantee you that they do 1,500 meters. I've done it. Ubiquity makes a pair of radios that go,
let's see if that works,
more or less 15 kilometers on 60 gigahertz. Unlicensed, full gig across that path. Willem can attest to the fact that they work at 4.3 miles. He gets his internet across that link. It just
it's also
works.
$400 per freaking radio.
Yeah, each side, they're a little bit bigger than this, and they're $400 each. So it's $800 for a set of radios, but it's really, really robust, and they work in high interference environments.
Okay, does everybody have a link? If you have a link, that's a good step, but you can't talk yet. You need to assign an IP address to either side of the link. So look at your worksheet and where it says WLAN IP address.
I thought you said this was 101.
It is 10101.
It's
so you need to go to IP. There's a question in I lost the chat.
I can't get to it. What's it say? The bigger ones or the little ones? We have two sets of them. We have the little ones and the bigger ones. The little radios are Mikrotik
the one that
wireless
says WLAN
wire.
is your address. You and your partner should have different addresses.
The bigger radios that we had that'll go 1,500 meters are called a Mikrotik N-Ray, N-R-A-Y, N-Ray. And those are they're under 300 for a pair.
Yes. For your WLAN address, you put in your WLAN address. That's on your worksheet. Right? You're going to be, one of you are going to be .1, the other one is going to be .2, right? You can't have the same IP address. You have to have a matching pair of IP addresses within the same subnet. So if you're the client side or the bridge side, you're going to do the .1 address. If you're the station bridge side, you're going to do the .2 address. In both cases, your worksheet should give you that address. It should say WLAN and then .1 and .2 for you and your partner. So you put in whatever your WLAN address is. Yeah, yes, you have to have the /24 at the end. Yeah, yes, whatever is on your sheet. And remember the /24 at the end. The /24 is very important.
Static route now. Which is 10. Gateway will be your 23.1.
After that, see if you can ping your partner across that bridge now. So if you're the .1 side, try to ping the .2 side. If you're the .2 side, try to ping the .1 side. Sorry, I'm a slide ahead. Make sure that you can actually ping across that bridge. If you can't, raise your hand. Ben will fix it.
If you, yeah, raise your hand, Ben will fix it.
It's broke, you fix. Well, just make sure that they don't have the same IP or something. This shouldn't be that hard. Half an hour at most. Okay, everybody, can you talk to your partner? Okay, so listen up. This is an important step here. So at this time, your neighbor's WLAN address is reachable, right? So at this time, you should be able to reach your neighbor's WLAN IP, right? The 10.88 address. You also wrote down your neighbor's bridge address. Can you ping it? Why not? Because there's no route that tells it to how to get to your neighbor's bridge address. It can get to its WLAN address, but you need to add the neighbor's bridge address. So what you need to do now is to add a new route. So you're going to do IP route, and for the destination address, you're going to put in your partner's bridge net address. It's the last thing on the worksheet. Now notice something about your partner's bridge address. It is not .1, it is .0/24 because it's the entirety of your partner's bridge, not just the bridge itself, right? So if I want to get into your partner's laptop to see what cool files he has on his laptop, I need to be able to get to any device within that subnet. So the destination address is 10.99. Whatever your partner's address is, .0/24, and the gateway is his WAN address, right? So the partner gateway is the one that's not yours. IP route. Routing is OSPF and stuff like that. So this is under IP route. Oh, yeah, sorry, it was on the, I showed you how to do routes before. I presumed that you knew how to do that. So IP routes. We're adding a new route. Correct.
Just remember, he has 2 PhDs after his name, and he assumes things. Which?
Your partner's gateway.
Your partner's gateway.
See, it's the neighboring WLAN IP, right?
So you'll notice in there, if it's not reachable, it's blue. If it's reachable, it's black. That does mean something. If it's blue, something's not right. You're probably pointing it at the wrong address.
Okay, so once that's happening, try to ping your partner's gateway again. So try to ping 10.99. Whatever your partner is. See if you can reach him. So I'm just going to do the default gateway and then we'll call it good.
We gotta set up routes.
If you're struggling, raise your hand. So do IP routes plus.
I got one here for a WLAN, but
Well, you need another one.
need another one, okay.
So the destination address is whatever his is. So 10.99 dot what is he 31 dot 0/24,
Okay.
and the gateway is the partner gateway. So 10.88 dot 15.2.
Yeah, that one, okay.
And then check gateway is ping. Check gateway. No, you're in type.
Wrong one.
Yep. Check gateway.
Get the
Okay. And then say okay. So now it tells you is that gateway is reachable via WLAN 1. So, everybody up to this point, remember this course is very comprehensive. Whatever wasn't covered during the class, we will cover on the final. So, welcome to the graduate version of Router OS. What we're now going to do is actually a very advanced topic, but I just wanted to show you this because it shows you the power of what we have achieved here. And that's sort of the end of this course, is just adding the second default route. So what I want you to do is to go to IP routes and add a new default route. But the new default route will point to your partner. So the destination address is still 000/0. The gateway is now the WLAN address, the same one that you just used to set up the connection to your partner's bridge address. You now make that the default address by saying that it's the same gateway. You check the gateway with pings. But here's the critical part. You set the distance equal to 2. So the distance equal to 2 says if there's a shorter way of doing it, don't do this. So it will not use this path unless the primary path, which is your wired connection, has failed.
Now notice that the wired connection says 1 for that distance. If your wired connection fails, it's going to take the next route, which has a distance of 2.
If you did this step correctly, the page will look like this. So notice that there are now 2 default addresses. One of them is blued out, and one is not.
Notice that the first part of the line, one says AS, that's active, and then the second line that's blued out doesn't have an A on it. A is active. It's waiting. And it will take over if your first route fails. That ping is always looking at that other gateway, and if that ping fails, it marks it as not active, and it'll fail to the next one.
Everybody there? Always the other side.
Always the other side. Next hop. The second route is the WLAN gateway, other side. Your partner's WLAN gateway.
I bet you on this instruction they're both going to unplug the one and then it's not going to work. So when you've done this step, one of you unplug the WAN, not both. If you both unplug the LAN, that kind of defeats the purpose, right? But if one of you unplug the Ethernet cord from this device, notice what's going to happen is that it's going to notice that this address is now unreachable because you just unplugged the cable. And instead, it's going to go via your partner. So try that and make sure it works. If it doesn't work, we broke something.
This is a very powerful tool, and we use it a lot to know when things break. You're beyond help. Ben can.
That's my partner's WLAN gateway.
You only have one route in here now. Where's
So if this step worked, close your books, put away your computers, and take one of the blue exam books over there in the corner for the final.
Well, look at my partner.
Well,
You can't do it.
he said it first, so it is your fault.
Getting timeouts on this. So here, I am on the network
Right?
and I can ping 8.8.8.
Okay. Can you ping his router address?
Yes. 40. At the 99.1. See if you can ping.
Okay. Does he have the route set back to you correctly? Because he needs to be able to do the same thing. If his device doesn't know your base address, it's not going to be able to route back to you.
Okay.
So you need to make sure that it also works on the other side.
You bring up ping and ping 1099.
Like you said, 5 times he's ever driven to the site doing remote configuration.
Okay.
Stuff in the rock.
And show me your, do you have your default route set? Yeah, you've got both your default routes set, and you have, and it's both reachable. Okay, so one of you, so that part works, right?
Yeah. So if I start pinging Google,
Right.
pop this.
It
switches,
falls over,
and then,
but it's not. So can you still ping 8.8.8?
He seems to be intermittent pinging that on a good time. I'm getting no
So
returns.
you're well. So try it the other way around. Because that's not horrible.
Okay, now I'm back. Now if I pop this one out. Oh, that's
But no, no. So it works this way, but not the other way.
so you're able to send it through me to Google.
Yes.
But not the other way. So you have NAT turned on.
Oh, he doesn't. I don't think he has NAT.
If you don't have NAT turned on, that's not going to work.
Okay, that's the problem.
So go to IP firewall,
IP firewall.
and then click the NAT tab. Okay, now click the plus. Source net is good. Go down to out interface. And that should be your LAN. And then go to action at the very top, the action tab. And then turn that to masquerade. And then okay. It's NAT. It basically means, right. That's okay. So now try it again.
That swaps with timeouts. I'm getting some through. I think his is.
Yeah.
But I'm getting some through, so.
Right. So the thing is, you are whatever address you are, right?
Yeah.
It knows that if it wants to go to 8.8, the only way out is to there. But it now needs to tell the rest of the network, not your address, but the NAT address, right? Then when the packet comes back, that packet needs to find its way back to you. So it'll come in as the NAT, gets reverse translated, and then there needs to be a route here back to you so that it can find your bridge address. That's why it's grad school. Anybody still struggling with failover? Whose head is not full yet? Is your head full? One of my favorite Calvin and Hobbes is where he says, "My head is full, may I be excused?" Well, I think we're there. So that's all I had for today. If you're still struggling with something, help us figure it out, or tell us so we can help you figure it out, but it's overwhelming. The key thing is that with Mikrotik, you have infinite configurability. I hope this just gave you a flavor of what you can do. If you want to know more, come back for the 201 course.
Willem? Willem?
Did I hear my name?
Yes, Willem. This is Bill at M5BB in New Mexico.
Yeah, can you turn it up? I can't hear. Go ahead, ask your question.
Yeah, Willem, is there a possibility that we can get a copy of the worksheet added to the syllabus so that we can work through that by ourselves?
Yes, I forgot to post the worksheet.
So what can we
with the
use
syllabus.
these
I
for?
sent one to Ed, but I didn't post it, so I will
Well,
get that posted.
That is a very, very, it's a very loaded question. What you have learned is how to be dangerous. And you can use these things with the config out of the box as just like a travel router. To do something a little more difficult requires a little more configuration, and you probably should ask somebody for a little bit of help, and a whole lot of us here know how to do this stuff. Willem, Mark, me, Ben, Joey Stanford in Longmont, James Cizik in Loveland. There's a lot of folks out there that can help you if you need to figure out how to do that stuff. Mark? You're on.
For uses that I use, I carry one in my bag when I go to a site. Sometimes I like to stay in the car and not have to run an Ethernet cable. So I can take one of these routers. I've got a 8 to 54 volt power converter that I can run it. I plug it into a site router and I can run Wi-Fi in the car, or I can connect my phone to it and make phone calls while I'm at a site where I don't have cellular service.
It's a cheap little easy way to get a Wi-Fi access point wherever you are. So you can do just about anything you want with this. We kind of use them for emergency access. We use them for in the point-to-point world, using the 60 gig stuff that I was showing you earlier. Tying two houses together, an outbuilding on your property, whatever you happen to need. It's really, if you have a need for it, there's probably a solution with Mikrotik in the world for you to be able to do this stuff. So if you have a need and you can't figure out how to solve it, just drop an email to one of us and we can probably help you get to that point. It's not challenging, but flexibility paves the road to futility. Just remember that. Yes. So, yeah, Dean had a good comment here. He says, don't let it frighten you. You'll never do anything if you let it frighten you. Just spend a little bit of time, dig into the hardware. I've been doing this since the late 90s. Didn't come easy to me. I set this hardware up on my bench and I started playing with it. Get a couple of cheap radios and try to configure them. Don't let it bother you. Just start playing with it. We're hams. That's what we do. Just take your time, enjoy it, ask questions. we're here to try to help solve these things for you. We probably won't build it for you, but we can certainly help you configure it. Hopefully that helps.
And we won't say, well, that's stupid. What are you trying to do here?
No, that's just remember, that's how we learn. Okay.
We'll figure out the solution.
Anything else? All right. Thanks,
you all.
everybody. Much appreciated. Hopefully you learned something.
The next RMHAM University is December.
Second Saturday in December.
Do we know what day that is? Second Saturday in December?
It's a thing. December 11th.
December 11th is Mike's
DMR workshop.
and again, it will be something very similar to this. Bring your laptop, bring your radio. We'll figure out how to program it.
Very good. Thank you all. Much appreciated.
Well, quick question. Totally off topic. Since you're an actual and apparently
And I play one on TV.
and you get paid for it. And
Well, I guess it's time to go, huh?
Something like that.
Well, it's been great. So I'm leaving.